Greetings and welcome, friends. Mr. Wadi here. We're on page 141. Perhaps you are as well. If not, I'll give you a moment. You can get your book. Maybe you're opening a PDF right now. Yeah. Okay, you're with me. I'm on page 141, Big Ideas, Algebra 1. And we're going to look at questions 5 and 6 real quick. It says, describe the slope of the line. All right. So as little Mario, he's red. He runs to the right. Is Mario going uphill or downhill as he would traverse this line? Yeah, so this is a negative. He's going down, negative slope. All right, because he's going down as we move to the right. Let's look at this one over here. As Mario's running to the right, doot, 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 doot. Is he going down or up? Is it positive or negative? Positive. Good, good. All right. Then it says, then find the slope. So we actually had a few ways of finding the slope. We want to, if I pick 2 points that land on the grid, right on those crosshairs, to find the slope, I figure out what is the rise. And in this case, the rise is falling. So we'll call that rise -3. And what is the run, which is the moving to the right, and in this case it is moving to the right, so it'll be a positive number, and that's moving over a 1, a 2, a 3, 4, 5. So the slope here, m, all right, is the variable they picked for slope. They didn't pick s because s was already typically used for the side length of a square, but m is for slope, and yes, I realize in English there are no letters in the word slope that have an m in it, but you could think about mountain. If you're going down a mountain in the steepness of a mountain or up a mountain, slope. So m is going to equal the rise over the run. It's the ratio of the change in y over the change in x. And in this case, it is just simply -3/5. And I can't reduce that fraction, so I'm good. And if I wanted to find another point on this line, I could find it by going down another 3 and over another 5. And actually, I would, if I did it correctly, bam, it would have worked. Or I could also go backwards 5 and up 3 and land on the line. So let's see, let's look at this one. Here the rise, it's going uphill. So the rise is, in fact, rising. It's going up 4 units, all units. And the run is 3. So the rise over the run, the m, is going to be up 4 over 3, or 4/3. And I should reduce that fraction if I can. However, in this case, I cannot. Now, let's think about this one more way, because reading it off the graph, I think, is the easiest way to really grasp it. But I want us to also become familiar with the slope formula. Actually, I'll even write its name down here. Slope formula. All right, this is a good one. You want to smuggle this in your brain box. This one, hold on to this, is y2 minus y1 over x2 minus x1. All right, slope formula. And I want to point out, it's actually describing the same thing. Notice this is the change in y. All right, this is describing the rise. The difference of my y coordinates is describing that distance, okay? And the denominator, the debotominator, is representing the change in x, okay? Where if I subtract these x coordinates, it is actually giving me the horizontal difference between those 2 points, is what that represents. Okay, yeah, that I was gonna, here you go, welcome back. So if I wanted to find the slope, let's do example 6. So my points were 1, -1, and 4, 3. Because sometimes you won't have a graph. Maybe you'll just have gotten the points, and it would save you a lot of time rather than creating a graph to just plug these values in a little formula, and it'll just give you the answer. But before we do that, we should actually label our points. So I'm going to label this my point 1. So I'll call that x1, y1, and this my point 2. So x2, y2, and now I just plug and chug, as they say. So m is equal to y2, right, minus y1, so 3 minus a -1 over x2 minus x1, so 4 minus 1. Now I'm expecting it to equal this. It should be the same thing. So 3 minus a negative 1 is 3 plus 1, which is 4, and 4 minus 1 is 3. So I do, in fact, get 4/3. Notice I also, in fact, had a positive slope here, and that's also what I was expected since the graph was rising as I run to the right. Okay, cool. So lots of components. Slope is rise over run. Slope is the change in y over the change in x. Slope is the difference of the y's over the difference of the x's in this formula. Lots of different ways of thinking about slope. Slope is simply a way to represent the steepness of the line. The rate of change is how we talked about it earlier. So there we go. Let's see. We might only do one of these for sake of time. We got a half day here today in the non-internet world. So yeah, I think so. So let's see. So change in y over change in x. So let's do the change in y first. So here's a table, and I'm going to find the change in y. And now I could actually pick, I could look at any 2 points. I could look at this point to this point. I could look at those 2 points. I could look at these 2 points. It doesn't matter which 2 ordered pairs I pick. It doesn't matter. All right, I just have to figure out what the change in y and the change in x are. So I don't know, I'll just pick these first 2 because that's probably what we would have done. So the change in y, to go from -2 to 0, it looks like it was adding 2. And the change in x, for those same 2 points, I can't just do the change in x over here or from here to here. I got to commit to those points. So this was my point 1 and my point 2 sort of thing. To go from -9 to -5, ooh, what is that changed by, guys? It's getting less negative, so it's addition. And how far apart were those numbers? 4. Well done. Well done. So my sloppy slope, m, is going to be the change in y, 2, over the change in x, 4, and that reduces to a half because both of those are divisible by 2. 2 goes into 2 once and into 4 twice. If you need practice reducing fractions, you could probably find a video somewhere on my channel about reducing fractions. You could also check out my man Sal Khan at khanacademy.org. He'll help you out with reducing your fractions. Good stuff. So that might be a prerequisite skill you should familiarize yourself with. I guess while we're here, I've already got this. Let's do this. Let me pick, I'll pick an arbitrary set of points though. Oh man, -19, that's starting to get a big-ish number. So I'm just picking different points. Let's look at the change in y. So to go from -5 to -19, it was getting more negative, so it's subtracting. And 19 minus 5 is 14. So it's getting negative. All right, the change in x, doesn't matter which points I picked as long as I commit to them. To go from -3 to -1 is actually growing. That's less negative. And 3 minus 1 is 2. So it went up to -3 plus 2 is -1. So my sloppy slope, my m, is going to equal -14 over 2, and I could reduce that. That's just -7. Which, why did I what? Yeah, it's the change in y over the change in x. So yeah, so I just have to remember that. And if I say the slope is -7, that's actually an awesome way to represent it, but I would like to point out that is the same as going down 7 and over 1, that a whole number still has a denominator of 1. So if you want to think about it explicitly in terms of rise and run, your run is 1 when there is none in the denominator, right? When there is no fraction. Okay, so last example. All right, ooh, guys, this is good. The graph shows the distance y in miles that a bus travels in x hours. Okay, find and interpret the slope of the line. Okay, so let's do the rise. And so let's see, what is this rise? Well, I don't want to count by these boxes. Also notice that this point doesn't land on the grid. So what is this rise? Well, I could do it by subtracting the y's. So maybe the slope formula would have been good, but I'll just point out that 120 minus 60 is what number? Happens to be 60. So there's my rise. And what is my run? Well, I'm going from 1 to 2. And so 2 minus 1 is 1. So the slope here is the rise over the run, 1. Okay? Now, let's think about these in terms of units. What was the rise measuring? It was measuring miles. Miles. And what was the run measuring? It was measuring hours. So this is the same. Notice this, guys. This is like big mind blower. Are you ready? The slope is 60 miles per hour, right? MPH, miles per hour. That is the speed of the bus. Yeah, Keanu Reeves, don't let this drop below, 55 miles an hour? Yeah, just keep it right there. That's perfect. Thank you, Keanu. Appreciate it. But yeah, the slope of the line is the rate of change. And in terms of units, the slope was miles over hours, miles per hour. That was the speed of the bus. Isn't that crazy? Right? Like there are so many implications of that. That concept alone can take you all the way to calculus, my friends. It's amazing. Have a great day, internet friends. Tienen un día lo más bien del mundo.